everyone. Today we are looking at different types of linear equations. So we've got the slope-intercept form, point-slope form, standard form, and then you've got a vertical line or horizontal line. So the first thing we have to do is write a linear equation of a line that goes through the point 0, 2 and has a slope of 1/3. Okay, so as far as the information they gave me the slope, so that is m in my equation. In fact, both of these equations have m, so they both use slope. And you can actually see in the name of the equation, it's called either slope-intercept form or point-slope form. So you can tell in the name of them that they use slope as well. And then the next piece of information we were given is this point 0, 2. This is actually a special kind of point. The point 0, 2 is on the y-axis. It's called the y-intercept. So I get the b off of that. It's the point 0b. So b is 2 in this case. The m is 1/3. If I've got the m and the b, I'm going to go with this first equation here, y equals mx plus b, the slope-intercept form. So write a linear equation. I'm going to write this slope-intercept form. Y equals 1/3 for m, and then x plus b. All right, so plus 2. There's my linear equation. Next up, write a linear equation that goes through the point -1, 0 and has a slope of 2. So they give us the slope again. Our slope is 2m, which means we got to have one of these equations with the m in it. Okay, so this xy point that they gave us is not the y-intercept, it's some other xy point. So any other generic xy point, we're going to call x1, y1. So that means that our x1 is the number -1 and the y1 is 0. Okay, so we have the m, we have the x1, the y1. That means we're going to go with the point-slope form. Okay, so y minus y1, which we identified y1 as 0. So y minus 0 equals m, which is a 2, times x minus x1. My x1 is a -1, so there are a few things we need to simplify here. Because we have x minus a -1, it turns into x plus 1. And then subtracting 0 doesn't change anything, so I'll just leave it as a y. All right, so here is our point-slope form of a linear equation. And then next up, again, write a linear equation that goes through the point -7, 9. Again, that's not my y-intercept, that point, so that is like an x1, y1 point. And it has undefined slope. Okay, so let's look at some of these other functions. A vertical line, every time, a vertical line has slope undefined. And then every time you have a totally horizontal line, the slope is 0. Okay, so this said that we have undefined slope. So it must be a vertical line, which is x equals some number. So I'm going to do x equals, and the x value in this xy point is -7. So I will do x equals -7. There is our equation for a vertical line. And then example 4 here says to find the slope and y-intercept of the line. It actually is pretty close to this standard form with an a, b, and c. The difference is I've got the a, I've got the b, but the c is on the other side of the equal sign. So if I want to make it fit the standard form, I can subtract the 6 over to the left side, and great, that's in standard form. Now, keep in mind though, the question is asking us to find the slope and the y-intercept, which my slope is the m, the y-intercept is the b. I don't have m or b in the standard form, so I actually am going to try to rewrite this into slope-intercept form. Yes, it is closest to standard form, but to answer the question, I need my slope-intercept form. So I'm going to try to get y equals mx plus b. I will add 4x to both sides. Okay, 3y equals 4x plus 6. I will now divide by 3 on both sides. I mean like the entire side. Like 4 is divided by 3, I got 4/3 x, and 6 is divided by 3, so we got a 2. Here's our y equals mx plus b, which is helpful because they said find the slope, like the m. All right, so I've got that, and you have to find the y-intercept, or the b, which we also found. So the slope is 4/3, positive 4/3, and the y-intercept is the point 0b, so 0, 2 in this case. So we found both of those pieces of information. Okay, so many different types of linear equations, but they are all graphs of straight lines. And let's see what can happen with some of our straight lines. You can have some parallel lines or some perpendicular lines, and it all has to do with this whole m, which again, m is like my slope. If my slopes of my two lines are equal to each other, then they are parallel. If my slopes are the negative reciprocal of each other, now let's break that down. Negative, as in you swapped the sign, and then reciprocal means like you flipped the fraction. So if your slopes are negative reciprocals of each other, it means you change the sign and flip the fraction. Okay, so let's do a couple examples here. Example 5, find the equation of the line through the point negative 2, 1. Again, this is not specifically the y-intercept. It is some other generic point. Okay, I'm gonna put that in green, like my x1, y1 point. So here's my just generic point here. And it's got to be parallel to the line y equals negative 12. Again, if it says y equals some number, there's no x at all, this has to be a horizontal line. Okay, so what I'm going to do with this horizontal line is I need to get the slope from that. And again, we have that up here. The slope of any horizontal line is 0. That means my m here is 0. So find an equation of the line through that point with a slope of 0. So I'm going to do y minus y1 equals m times x minus x1. All right, I will simplify this down. The whole 0 times anything is 0 still. So the whole right side of the equation is a 0. And then if I add 1 to both sides, I get y equals 1. So this is actually another horizontal line, which on the graph, if you have y equals negative 12, if you got down negative 12, you have a horizontal line there. And then you've got to go through the point negative 2, 1. You got to go through that point and be parallel to it. So you have another horizontal line going through that point. It is the equation y equals 1. So they're both totally horizontal lines. Example 6, it says to write the standard form of the equation of the line through the point 1, negative 3. It's not a y-intercept, it's a generic x1, y1 point. So we got to go through that point and perpendicular. Okay, we've got to be perpendicular to 3x plus 2y minus 8 equals 0. Perpendicular, like I highlighted, it means you have to have the negative reciprocal of each other, of the slopes. So let's work on that first. Let's get the negative reciprocal of that slope. I got to find what the slope even is to begin with, and then I can get the negative reciprocal of it. So the reason I can't tell what slope this is because it's in standard form. And standard form doesn't give me the slope. So I'm going to try to rearrange this first. Try to get it to look like y equals mx plus b, so I can see my m, I can see my slope. Okay, so I added 8 on both sides, subtract 3x on both sides. Divide by 2 on both sides. Okay, so we've got y equals -3/2 x plus 4. Okay, that helped me get the slope. Now, again, what I highlighted in yellow is the fact that a perpendicular line is what I'm going for. That means I need the negative reciprocal of this slope. Negative, like change the sign, it's going to turn into a new slope that is positive, and reciprocal, like flip the fraction. So I get a positive 2/3. There's the slope of the line that we're going to make. Okay, so it says to write the standard form of the equation of a line, but the information I have is a point and I have the slope. So I'm going to start with point slope form, just based off the information I have. So I do y minus y1, that was my -3 there, y minus y1 equals m, which we found was a positive 2/3, times x minus x1. Okay, so this is an equation of a perpendicular line, but they said they wanted specifically a standard form of the equation. So let's kind of rearrange this. Minus and negative is addition, so y plus 3. And then, I don't know about you guys, but I'm not a big fan of these fractions. If I can avoid that, I will. So I am going to multiply both sides of the equation times 3. So I get a 3y plus 9 equals, and then I'm multiplying by 3 and dividing by 3. So those inverses have undone each other. We now have 2 times x minus 1. Yay, no more fractions. Okay, so 3y plus 9 equals, if I distribute, I get a 2x minus 2. Again, I'm trying to get everything on the same side. So I will subtract the 2x on both sides, and I'll add the 2 over on both sides to get down to standard form. So I've got a 3y minus a 2x plus 11 equals 0. Okay, so you can rearrange this if you like. You can turn it into negative 2x plus 3y plus 11 equals 0. It's the same thing. They have everything on the left side of the equation, so this is standard form. It is perpendicular to the equation they gave us, and it goes through the point 1, -3.